Okay, so today we're going to look at solving simultaneous equations because we need to be able to find the point where graphs intersect. So in this particular standard, it's really important that we're doing it as far as a graphical sense. There are lots of reasons why we might solve simultaneous equations, but in this particular standard, we're looking for the points where two lines intersect so that we can prove certain things about shapes and things like that. Last year when you were in year 11, you had to do it by hand because you weren't allowed to use a calculator, but luckily this year you're allowed to use a calculator. There are times, though, when sometimes it's faster to do it without the calculator because the equation isn't written in the right form. So let's just have a look at one, then we'll do by hand, and then we'll turn it into something we can put in our graphics calculator to solve. Okay? Y equals a half x minus 2, 3x minus 2y equals 6. So these are two graphs. The first one's written in the form of y equals mx plus c. So we've got the gradient intercept method. And the second one is written in x plus y equals k, which is our cover-up method. So two different ways of putting these on a graph, but we're not going to worry about the graph today. So what we have here is two equations with x and y in them. The x and the y are exactly the same value, whatever that happens to be, in both of these equations. So anytime y is mentioned, it's the same as any other y in the equation. So here, this y says that it's equal to half x minus 2. So this y here is also equal to a half x minus 2. And that's where it becomes helpful. So we use that method called substitution. And if you look at my 1.2 simultaneous equations videos, you'll see that one of the methods is called substitution and one elimination. This particular method is quite good when we've got a y equals method. So this y and this y are the same value. We don't know what that value is, but we want to find it out. So I'm going to put this thing here in here for y. So I'm going to have 3x minus 2 of these. All right? So when I multiply this out, I'm going to get 3x minus 2 times a half is 1, so a half, 1x, negative 2 times negative 2 is positive 4 equals 6. So we've got 2x equals 6, take away 4 is 2, x equals 1. That's nice. Now we're going to go back to here and find out what the y value is because we're finding a coordinate on a graph, so it's important to find x and y. So y equals a half of whatever x is minus 2. So a half of 1 minus 2 is equal to negative 1 1/2. All right? So our answer is that coordinate, 1, negative 1 1/2. Okay. So, as I said, we're allowed to use our graphics calculator. We use that by using the equations mode and then looking for F1 simultaneous equations and variables 2, but we need it in this form. So we need to have it written as something x plus something y equals some number. So you can see that these equations aren't perfectly in that form. This one is, this one isn't. So we're going to rewrite the first equation. So we've got y equals a half x minus 2. We need it written like this. So we need to bring the x over this side and get negative a half x plus y equals negative 2. We can do it like that, or we might not like that negative a half, so we might double the whole thing. We can do that as well. But we can put negative a half in our calculator. So we've got a equals negative a half, b equals the number in front of y, which is there is 1y, so it's 1, and c equals negative 2. In the second equation, 3x minus 2y equals 6, we've got a equals 3, b equals negative 2. Be careful with the signs, guys, because if you get the signs wrong, you'll get the answer wrong. It'll still find you an answer most of the time. All right? So these are the numbers we're putting into our calculator. Away you go. So get your calculator. Go to equations. It's 8 on mine. F1 for simultaneous equations. 2 variables, x and y. Right, now in that little matrixy thing, we need to add in all these numbers. So we've got -1/2, 1, -2, 3, -2, 6, EXE, and hopefully, almost definitely, you're going to get the answer of 1 and -1.5. But if you look down in the bottom right-hand side, you'll see that this number has been written as a fraction. And most of the time you want to write it as a fraction. So read that number and change that to 1/2. It's exactly the same when it's 0.5, but it's not the same when it's some of those weird numbers like 1/8 and 1/12 or things like that. So look for the actual fraction because it's perfectly correct. All right.